Well, hi, good morning. Thanks so much for joining me in my shop. Hey, my objective today will be to operate this radio and poke around with instruments, compare it to the schematic I have, which appears to be pretty much correct, and see if I can find any voltages that are low or anything out of sorts that might guide me towards more defective components. And that's before I do a general change out of these last few capacitors. So one of the good reasons for doing this at this point is I've taken out one capacitor anyway that I've tested, and that's this one here, and it proved to be good. Doesn't look good, proved to be good though. Good chance the rest of them are also good. They've been hanging out together for a long time here in this radio. So but first I was just looking at the schematic before I clicked on the video. I'm going to look at the schematic with you at a note, which is the strangest note I've ever seen on a schematic. Maybe I'm misinterpreting it, but let's take a look here and see. Okay, so there's the schematic on here. Now this is a really nice schematic, by the way. Whoever drafted this, a person long in the grave, I'm sure, did a nice job on this schematic. So I was just looking over a couple of notes, and these ones caught my attention because I was thinking about these IF transformers and aligning them today. I might get to the point where I can align these two transformers. So I was just looking at the notes around them to see if there was anything unusual about them. Well, this is a little odd. Look at this. I didn't notice this before. With another battery. I think in the radio I have, this battery exists. I haven't seen another battery, so I'm gonna have to guess this coil doesn't exist either. Anyway, that's interesting, but even more interesting are these notes right here. So let me turn this so we can read the notes directly. Where'd they go? Here they are here. Look at this. 60347. Fall production, less reaction. WDG, I think is what that says. 60247, spring production with reaction, winding. That's what that would be. Okay, now I understand this. Fall production, less reaction, winding. That's this. This must be a reaction winding. That's what they're calling it. Reaction winding. But then in the spring, I guess the engineers wisened up and included this feature in the radio. Spring production with that has to be production. What else could that possibly mean? Oop, that's not quite what I wanted to do here. Here we are. Let's zoom in a little more on this. Okay, so let's rotate. There we are. Fall production, less reaction winding. With reaction winding. Dotted lines, yeah. So you know what that kind of says? That they were changing the circuitry in this radio in the midst of its production. And here they put a note right on here. Tuning meter. No, there's no tuning meter in this radio. So anyway, I just thought I'd show you that note. I've never seen anything like that. Of course, this whole radio has been kind of a weird journey. Okay, back to the radio. So, I want to try something a little different here while I'm working on the radio today, and I want to utilize this clamp-on meter, which I picked up some time ago. Hadn't made much use of it, and I realized that there are some wires free enough in this radio. I could actually put a clamp-on ammeter around it, and this little meter will read milliamps of DC. So there's some challenges in using this, but I'm going to try to use this here and there as part of the poke around process. The other thing I'm going to use is this meter here for poking around. Beautiful, beautiful sunny day today, but a little bit cold. I think I can stick that under there. Yeah, a little bit cold outside, just a bit above, just a bit below zero. So, and I know at this point in time, over in the UK and through Europe, there's a weather disaster going on with very, very cold, snowy weather, so I feel for you guys. But my head is framed around springtime here right now. Snow in the forecast a few days from now, but I don't know if it's a lot or a little. I'm a Canadian. I love to talk about the weather. What can I say? Okay. So we'll switch this guy on. We'll keep the volume low while we're doing this. Is everything okay? Everything looks okay. Another thing we're going to do is we're going to temporarily anyway raise this up to full line voltage, 120 volts, or what is it today? It's 117 on my meter here. And check again the temperature of this resistor I installed yesterday. Can I stick my finger in there right now with a working radio? So a couple of you, and thanks again for the comments, and I'm getting a few emails and attachments and stuff like that. I appreciate the help. Thank you very much. Looks like I calculated this pretty close, because I guess it's on the schematic, and we could look again, but I won't right now. But apparently it's on the schematic somewhere, and it shows it as a 25K, and I had calculated 22 there. I actually put in a 20, so it's a little low. 20 instead of 25. Is that enough to cause it to burn up? Number two, I think I put in a 2-watt resistor. I can't remember now what the wattage is of these resistors. I remember when I bought them, I thought, wow, that's pretty high wattage for what they look like. So I may have put something in here that's a little small wattage wise. So I want to keep an eye on that, and let's do that right now. Okay, 20 this morning. It's -7 outside. Okay, it's been on for a couple minutes. Last time I think the highest I got was like a 35. Oh, you know what? I know what's happening now. You see, I think I'm not going to be able to use this. Cat, be careful, because I squeeze the trigger. I don't dare do it now. I squeeze the trigger. See, she's looking everywhere. A laser light comes out. Look at her looking everywhere for it. She's looking for the laser light. She knows the beep sound from here, and she'll come running right through the house to come check it out. What am I going to do? So here's what I'm going to do. Okay, we're going to fool the cat out of here. Come on over. Here we go. This is what we got to do. Sorry about the camera work here. It's just a little awkward turning it around. Okay. You ready? And goodbye, your shadow. Oh, I feel so guilty. I feel terribly guilty. The poor cat, because she's going to hear this thing beeping. I'll bet you we'll hear her claws on the door before long. It's going to want to come in. What's going on with that? Meanwhile, the resistor is burned away, eh? Listen. Oh, she was meowing there. This is going to drive her nuts. What can I do? 34. 34. Just looking for the highest reading. 35. Okay, so 34, 35. That's not very hot. These things should be able to go to 50. And potentially quite a bit higher, in fact. Not that we want something at 50 degrees in here. I also found the switch was warming up. Is that still the case today? Let's see. Okay, so chassis is reading... That's the cat. Chassis is reading 21. 24. Poor thing. 26. So definitely the switch is heating up a bit. Nothing else was significantly heating in here. So should we do the heat run right away? I want to do the heat run, run the set on full voltage, and then do all the voltage tests on full voltage. One of the very first ones being, what is the screen voltage where that resistor went? So what's the worst case here? I've had it on full voltage a few times and nothing's happened, so shouldn't be too worried. Screen voltage goes a little high. On the schematic it's shown quite low at 75. Maybe it's going to go a little high. I don't know. I don't think it's a concern. Certainly not for a short period. Okay, one more check. 34. 35. Now we're going to put it up to full voltage here. A little bit of sound coming out of the speaker. A little more sound, rather. $42, $45. I'm not sure you can see the numbers, so I'm calling them out. 47. So my guess is that resistor itself is like 55 degrees. I wouldn't want to put a finger on it. You know, it doesn't look good. It does not look good. Quickly, let's get the not looking good picture on the screen here. What is not looking good? Come on, please, camera, focus. It looks wet. It looks wet and a little bit misshapen. Of course, it can't be wet. See the shape of it? Let me get another one of those out. I think that resistor is leaving us right now. Let me get another one to look at. There, just in case something exciting happens. Keep an eye on it there for me, would you? Let me know if it explodes. Okay, so here's another one. You know, it has the same kind of crummy shape to it. Let's just compare it here. I don't want to hold it right in the radio. That would be a little too exciting. So it's a bit of a dumbbell shape, isn't it? With a wee bit of a rise right in the middle. Take a little bit of a risk and hold this right in here. I think I'm worried about nothing. Oh, jeepers. Okay, I gotta fix the focus here. I can't stand the autofocus situation. Sorry I didn't do this before turning on the cameras, but forever forget to do this. Here. Okay, we'll focus, something like that. I don't think it's any different. I think I'm imagining the distortion in it. Maybe it says right on the little slip here what the wattage is. No. Doesn't. So what I could do, though, easily enough, is that's supposed to be, that's supposed to be a 25K. I could add in a 5. And have both that and the 5 going, and I think both of them would be cooler, much cooler. But I'm not going to panic over it. Oh, that was the speaker making that sound. Something did a little jump there. So as I explained the other day, with this speaker being so rattly, if you drive the cone any distance, it's going to sound just like you heard that sound. So something kind of popped in here. Maybe me touching something briefly. I don't know. Oh, there she goes again. Okay, was that this ground lead doing that, or is there something in the radio? It was this volume control was wonky. I wonder if it's this solder joint that's actually the one that's against the chassis here that's failed. I wonder if that's really where the noise is coming from. Okay. Finger on the chassis. Nope. favorite pastimes, poking around, literally. You ever wonder how wires get broken in radios? What if I finish the thought? Hey, fixed it. Okay, quickly, let's read that. Stop goofing around and read that. Hey, this is a noisy maker. A noisy maker. Let's read that screen voltage. So we're on the 500 volt scale on the meter, which is pretty high. Let's put it on a 150. Okay, 150. What is on the screen? So that would be about half of 150 there, which is about 75. If I actually read the number, 82 on the meter. So I think that makes sense. You put a 25 in here, it would probably drop it right into the 75 range, but I'm sure we're okay. Wow, something very sensitive now. Let's find it. It's a come and go. It's a coming and a going. What's happening there? One band is full of life, the others aren't. Turn it down. This is the AM radio band. There was a comment about not being able to hear the speaker. It sounds plenty loud to me, and the microphone's just kind of right out of view, just 2 feet away. So I think maybe I just had it quiet at that part of the video. Very good. Okay, volume down again. Try not. Let's see if we can keep on track. Let's try some of these DC measurements here. See, it looks like a default. I don't use this very much, so I got to be a little careful. So it's on DC now. 2 amps full scale, so that would be 2 point, and then this is all milliamps down here. So right now it's reading 91 milliamps. You might wonder, well, why is it doing that? It's doing that because of the Earth's magnetic field. So if I kind of rotate this around, you can see the numbers change wildly. So that's the trick in using these things. You have to cancel out the Earth's magnetic field just as you go to make the measurement. And that's tricky business. Like, let's see if I can show you what's tricky about it. So let's say you zero this meter right now. But now you go to put it around the wire. You're not going to be able to see what happens here. As I rotate it, it stayed zero, in fact. No, it went up a little wee bit. So you can't be holding it in your hand, zero it, put it in a circuit without having extra milliamps. Since we're going to read a very low current here, how to get this right. So one way would be to put it in place, shut the unit off, zero it, turn the unit back on. Turn the radio back on. Another way is you hold it almost in place. That's what I'm going to try. Let me see if I can get this on a camera here so you can see this happen. Okay, oh, focus deal, focus man. Oops, sorry. I'm clumsy on the mouse there. So now you should be able to see the reading. I gotta be careful. I'm looking at the computer screen while I'm doing this. It's really kind of risky. So you see there's some number on there, 45, something like that. So without looking at the screen, the computer screen, I hope you're seeing this. I hold it almost in position, zero it, Open. Sesame. Grab the wire. What do we got? Look at, see, I just rotate this a bit. Yeah, this is bull. This is bogus. Yeah, we're not going to be able to rely on that at all. And that's why I haven't been using this. Yeah, that's not going to work. Not reliably enough. AC would be different because the AC readings are not affected by the Earth's magnetic field. Well, I'm a little bit disappointed there. I was looking forward to, for the first time, reading currents directly. You know, that's challenging in a radio like this, to read actual currents. Sometimes you really need to read a plate current or something. Doing it directly would be kind of neat, but not going to happen. So let's look at a couple other voltages here. 275 is what is supposed to be the plate voltage in the radio. So that's on the 500 volt scale now. You see that's about, okay, to read it exactly, on the 500, that is 305, 310 volts, in that range. But it could be, I might have to look at the circuit diagram, but I think it's dropped off on the way to a tube. So let's pick a tube. The best tube to pick is the output tube. You see the maximum plate voltage. That's way up in the top here. Wow, I don't know about sticking a probe in there. I'm looking for what is most likely to be, I think it might be this right here. Okay, so on the meter we're getting 300. Okay, so according to the schematic it should be 275. Yeah, we're getting an extra 25 volts for free. Fantastic. Now, what other tubes in here? Now, there's a number of tubes that may have screen voltages. Maybe I should look at all the screen voltages that should be in here. So, tubes with screens. This 6K7, one of which we did. We should do the other one. Let's do the other one because I know it's pin 4. The other one is here. Pin 4. From memory. Oh, that's scary. 1, 2, 3, 4. I see pin 4. I see there's another tube socket put in with square nuts. I hadn't noticed it before. So this tube socket is an unusual thing to use a square nut. I mean, normally they're hexagonal. Isn't that what they usually are? No, I counted and then forgot. I got so excited about this. Square nuts. Okay, there we go. 1, 2, 3, 4. 4 kind of up in the back. More frayed insulation there. It's very hard to see. Okay, so there's the reading. And that's about 75, because that's the 150 volt scale. So about 75. Okay, that's very good. Let's check the bias on the output. No, keep going on the screen thing. Okay, so the 688 appears to have a screen. Oh my gosh, can I see it on the schematic here? Ooh, a screen. I can't tell looking at that. A8. Tricky to find that. How do they do their numbering here? Well, they don't do it like that. Okay, sorry. Apologies all around. 6A8. 6A8. So we got a suppressor, we got So we got a control grid screen, suppressor, control grid, suppressor plate. The second screen out from the grid is the second grid out from the cathode. Boy, what did I just say? I feel bad now when I hear news people talking live on the TV and they use the wrong word, and you can tell, I mentioned this before, they have no clue that they've used the wrong word. And I experienced this in here, where I watch a video and I see myself say something, and I think, well, I remember what was in my head at that moment, and it was not that. That's a scary notion, isn't it? That leads to these arguments we've had all through life, which I never have anymore, where I say, I didn't say that. Why would I say that? I would never say that. I remember what I said. I don't have those arguments anymore. I just go, oh, I'm sorry. So there we are. It's pin number 6. 1, 2, 3, 4, 5, 6. Pin number 6. Screen on the 6A8 tube. 6A8 is right up. It's right. Where is it? 6A8. Where are you, tube? It's really hidden from view. I just want to... Really, this is what's going to happen? I'm not going to be able to spot a tube now. Holy smokes. I've lost my mind. 6A8 has to be this one down here. Okay, my mind is returned. I found it. It wasn't gone for long. I don't know what it was doing while it was gone. Son of a gun. 6A8, pin number, remember it this time, 6. Don't forget it. Pin number 6. 6A8 is that tube. That's the one that I did that. I've already checked the 6A8. That's the one I put the capacitor on, for crying out loud. So all we're left with now is the output tube. 6F6. 6F6. Screen, second grid in pin 4. Pin 4. Oh, it's not a 6F6, it's a 42. Come on. Come on, man. Forty-two. 42. Screen 3. 3 for screen. Oh, now there's no key on this tube. It's a 6-pin tube. I have to recognize the fat guys. There they are right there. Easily recognized. 1, 2, 3. 3 is this here. Let's try that again. 3 is on this wire over here. That went right over. Oh. Come here. It's not necessarily wrong. So that's got like full. That's got 250 volts on it. Maybe on the schematic it reveals what the screen voltage is supposed to be on the 42. No. I think the schematic I have shows a 6F6. 42. This is a little tricky to look up because I think 42 says go look at 6F6 for everything. 42. tube requires 6 contact heater volts. This type electrically identical with 6F6. Okay, so 6F6. 6F6. So what we're looking for now is typical screen voltage. Grid 2 screen voltage 285 max with 375 plate voltage, but we don't have 375 plate voltage. So, 285 max there. Typical operation. Grid number 2 supply voltage, fixed bias, that's how it's operating. No, it's cathode bias. Cathode bias, come over here, it's the same numbers anyway. Plate supply 250 and grid number 2, 250. Look, it's the same. Look, it's the same. So that's fine. Generally, as I understand it, you want the screen generally a little lower than the plate, never higher. So in this case, this particular tube works fine with the same voltage. And that's what we got there. Okay. Very good. I think we're good. There's another busy tube in here. That's the oscillator tube. That's a 6A7's the oscillator tube. That's the detector tube. 6Q7. Wasn't it? 6Q7. Let's just take a peek at that. Okay, so what I'm just trying to do is ensure the high voltages on these tubes is correct. I kind of know the plate's okay because the radio's working. I can't talk and work the alphabet at the same time. 6Q, 6 TUV, QRX, D2. Okay, it's back this way. Hey, wait. What happened? 6Q7. There it is, hidden right there. Okay, so this guy is basically a I knew this already. Triode with 2 diodes. So there's no screen, there's no suppressor, there's no screen voltage to worry about. And when it's being used as a detector, there isn't even necessarily any plate voltage. I believe. Well, nothing seems amiss. Nothing's overheating terribly. I really think I should fiddle around with the alignment at this point. I think that might be a good idea. Certainly if there's something out of sorts here, it's not the kind of thing that's going to damage the radio at all. My objective now is to pick up the performance of the radio in terms of tuning it, aligning it. We'll see what we got at that point. If one of the bands appears to be dead or something's still not working, then I'll go hunting for more component problems, failures. And beyond that, I'll just go in and kind of routinely change a few more capacitors here. I think I'll be pretty much done with it at that point. The speaker still remains a bit of a problem, but you know what, I may not be the last guy to work on this radio. This radio may go from my hands through somebody into somebody else's hands, similar to me, who may continue on working on it. What that person would know at this point is that this radio has the capability of working, because it would arrive in their hands working. Could it work better? Well, maybe that would be their fun. Get in here, change all these wires, and they can have a great time with it. Fix up the cabinet, end up with a beautiful radio. And not pay a lot going into it. So what I think I'll do is I'll stop the video, I'll set up the whole deal here to do an alignment. I have to read the alignment instructions too a little bit. And then we'll head for doing just the IF alignment and see what kind of a lift we can get out of it right there. Okay, I'll be back in seconds in video time. Okay, so here's some alignment information that relates to this radio or a radio very similar. You can see this is model 818283. My radio has a plaque on the back, says 93. Looks like it's some botched combination of these two radios. Just some clear differences between these radios. First of all, that's the output tube. Look, 6F6, not 42. And what's an electrical condenser? Okay, that's funny. I must have seen another diagram of this radio then that shows a tube sitting right here just like on mine. And the tube is the preamp to drive the output tube. Wow, this has got two condensers here. There's another one over here. Wow, okay, I don't know. Anyway, not to worry about it. This won't stop me from doing what I'm doing, which is tuning these two IF transformers here. And this radio, look, here's another thing. Look at that, Magic Eye, which doesn't exist in this radio at all. And down here, it looks like it's got 3 antenna connections. 3 or what's this? Oh, these are adjustments. They're showing there's an adjustment for it says tracking coils. This is a will change the oscillator frequency, I believe, right from the back apron. You know, a lot of radios have been built so you can align them without pulling them out of the cabinet. You can reach in there with tools or come through the apron or the side of the chassis, stuff like that. Okay, what's it say here? The usual stuff. Manual volume control should always be kept at maximum. Signal in the test oscillator should be kept as low as possible. Why? So that the signal should not be of sufficient strength to bring the automatic volume control into operation. Now, I've aligned a lot of radios by actually measuring the AVC voltage as I align it. In following this instruction, you can't do that because the objective is to keep the signal level so low there is no AVC. AVC is developed by rectifying the signal coming out of the IF stages. So that's why I've hooked up my meter to the speaker, which means we're going to have to listen to some sound while I do this. Set the gain capacitor at minimum capacity. Supply a modulated 462.5 signal to the grid cap of the 6A8 converter through a 0.1 millifarad capacitor, leaving the grid connector in place. Adjust in order 16, 15, 14, 13, that's these. 16, 15, 14, 13 for maximum output. And then we're on to something else. Okay, so that's what we got to do. So what I've got here is I've got a really nice meter here hooked up to the speaker. Can you see the wire? You see the wire returning here, going into the voice coil of the speaker. We're on the 1 volt scale here. A little bit of dirt in the switch. And this is a logarithmic meter, calibrated in decibels. Can I put it that way? So consequently, there's no zero. There's no zero on this meter. I'm going to take off the antenna. We don't want that. Turn up the volume a little bit. Let's see what happens here. Okay, since I took the antenna off, I know this from setting this up. Let me just put it on for a minute. Hold your ears. Wow. Okay, you should have seen that meter go crazy there. We don't want a signal coming in there. Instead, we're going to try to jam the signal into the grid cap. Let me turn this guy down because I have the feeling this to be a little loud. Now we're supposed to have it turned wide open. I should have put the knob on here. Just up a little bit. Okay. Okay. And we're going to stick this on here. That's a heck of a finger, eh? I can stick it right up here. Next stage is to take the signal generator output, re-aim things here. This is where the excitement is now. Signal generator output meter, frequency being put in, leads. Okay, so one of these got to go on ground. Ooh, that might not be the best ground because things are a little loose. Here, I haven't fixed that yet. Shame on me. We'll go on the screw head here, or nut or bolt or whatever it is. Now, before I hook this up, get this floppy wire laying around. Let's take a look at the signal generator. What did it say we were supposed to do this at? Gain capacitor fully open. Can I do it from here? Oh, all that noise I might have been hearing when I'm tapping the volume control is this thing rocking around. The whole, this whole piece rocking around. I don't like that, but let's keep going for now. Yeah, I can. That's almost certainly what it was. Everybody okay? What exactly happened there? This light did something weird. Now I'm nervous. Hey, the sweat is returning here. Okay. Let's tune it by the tuning control, which is way out of reach. Let's. So, ooh, geez, that's just scary sounds. Wow, that was magic. Funny stuff going on here. How can it receive so well? How can it receive that well? There's no antenna. Okay, she's open. Let's take this off. Huh. I don't know what to make of all that. Back on. Okay, the signal generator's output impedance is low, so this is a little like hooking up a short circuit. So whatever was in there making that sound you were listening to has been drained away now, literally, by the signal generator. But its own signal will come in here with some strength. So that's the theory, anyway. So this should be tuned to 462.5. This should be tuned to 462.5. The output level is very low. Let's turn it up a little bit. That's moderate. There she goes. It's pretty darn good. Pretty nice. I'm listening to just one rising peak. So we'll go 462, and there's the half. Oh, sorry about the focus there. 462. Yeah, you have to realize when I'm doing this, I'm only glancing up at the screen occasionally when I get a chance. So you have the pleasure of seeing things I don't realize are going on the video, or that are happening to the video. So now we got a nice audio level here. Let's get it up on the meter. Everybody hold still. What are you doing there, meter? Looks like I got another little job to do. Okay, now to verify that this is the tone we're hearing, I'm going to increase the modulation level in the signal we're sending. We should see the meter go up a bit. There we are. The modulation itself is running around 30%. Everything is ready to go. Now these are the guys I got to turn. First we're going to try with a metal screwdriver. What? Yes. And we'll see if using a metal screwdriver throws it off. Check them all. These are capacitors. They generally are impervious to the tool you're sticking in the screw. Now that moved a bit. Let's just try that again. And that could be touching the screw. It's actually moving the screw a little bit and adjusting it. So, this, and this. Here we go. First time this thing's been adjusted, maybe since the day it came out of the factory, for all I know. Down. And right on the money. Often these are, the IF is tuned correct. Often nothing has changed after all these years. But just a touch more out of that one. Okay. Sometimes with the radios you get a huge pickup here. And if one of them appears to change it a lot, then you got to go back and forth. A little change, not a big deal, just to, oops, just to do it once. Oh, what happened there? I don't think that was the radio. I think that was my equipment doing that. Just watching that meter. Go back. That one didn't make much difference. Let's just check this one here. So why would one of the four be out? How come they aren't all out or all not out? Could be it was never adjusted correctly right from the start. It's not very reassuring, is it? I think it's this grid cap. This is the tube I can't sink all the way down to the chassis also because of these little clips here, which I better not point around with a metal screwdriver. These shield clips. There used to be a glass tube in here originally, just a glass, and then a metal sleeve shield slid over it and down into these clips. Now they just interfere with this tube. This tube has its own shielding. It's a metal tube. Well, that's pretty stable now. How? I don't know. Seems okay. So there we are. So IF, we barely got a lift on it. Not much at all. But now we know. Now we know. Now we know. We know the IF is good. So any weakness in reception has to be coming from the other alignment issues, which are all these coils, and there's capacitors back here. Should we carry on? Where are we at here? I think a good thing to do at this point would be again to listen to the radio and call it a day at that point. Okay, so to do that, I'm going to turn it down. Take this off. Put the antenna on. Antenna, remember, is just a chunk of wire laying on the floor beside me, more or less. Not much of an antenna. Okay, turn it up now. Okay, I think we're on the AM band. We'll tune through. if I can turn this. It's more interesting to look at the front of the radio here. Wrong control check. So if you wanted to look at one of these pointers, it's this bent one, so we're up around here, in fact. Oh, jeez, really? 10 volts? Oh, what's going on there? Okay, something funny's happened with my... yeah, I think what's happened with this meter is the wires come off on the speaker and it's just reading... yeah, okay, that's off. Don't look at that. So that's a fairly strong, fairly local French AM station. Okay, so it's really the short wave band I'm kind of interested in. I think this is the low shortwave band. 5.2 megahertz, 1.6. This is just right above the AM band, and then it carries on up to 5. So we'll be starting at 5 and going down. No, we're not. No, we're not. No, we're not. Oh, I've got my phone here. I hope there haven't been a lot of phone interference. That was Thomas ringing in with an email. Okay. So I wouldn't expect to hear anything down here at all. But the wrong length antenna, wrong time of day, and there's nothing down here normally anyway but a bunch of noise. You gotta get up around 4.5 megahertz, 4 megahertz, start picking up some shortwave. That's been my experience. Getting a little quiet there. So you might hear something up here, but not very likely. So what that means is that this test, even though we don't hear radio stations, doesn't mean the radio's not working. In fact, you know what I'm going to do? I'm going to dial this to... yeah, listen to that speaker. I'm going to dial this to around 3. And then we're going to shoot it with some 3. We're going to give it a little bit of 3 here, using the signal generator. That kind of quieted it down. Okay, 3. So I want to get 3. Bit of gusto in this signal here. There we are. 2.9. Perfect. Okay, so so it's working. It's definitely working. Even though it doesn't pick anybody up yet. Okay, next band. Smart. Volume down. Volume up. Ooh, gotta turn this up a long ways. Kind of in the middle here now. So this has got a fast and slow tuning knob. Fast on the outside, slow on the inside. This shortwave band is really jammed. There's a lot happening when you move this just a little ways, so I better use the fine tuning on here. Thought I heard a voice there. Imagination. So where are we actually on the band here? I can hardly read it. I actually cannot read that. 49 meters, so we're down at the bottom here. This is 5.3, so it's just carrying on from where the other band ended, of course. So we'll get the pointer here, and then we'll work our way up to the high end. The high end's where we might actually pick something up. So let's get here. That's my signal generator. Oh, that speaker really is just not going to win. It's not going to win the day, is it? Ooh. I know what's coming up on the list. What's coming up higher on the list is stabilizing this whole frame here, so we don't get all this rattly noise. I think that's where a lot of it's coming from. I gotta move that up. Okay, here we go. Might get something up around in here. That's what I would think. What time is it now? It's 10 to 10 in the morning. I remember in college doing this on my shortwave radio with an antenna 250 feet in the air. Yes, I had an antenna 250 feet in the air on the top of an apartment building. And the sun cycle was high at that time. I literally turned the dial on the radio, and all you'd hear was just stuff being tuned through. Just an endless supply of broadcast stations and all kinds of utility stuff, military stuff, boats, everything. Not quite like that anymore. My antenna is actually laying on the floor of a basement right now. So. Hey! Fading a bit, I think.
This show is produced by Lasso Broadcasting and are grateful to its sponsors. See you next week. From Studio B.
I'm sure that's a religious station singing about freedom. I really, man, the mix between religion and politics at this point. Wasn't there some kind of social contract that the two of them would not get mixed up? And that politics could carry on without religion, religion could carry on without politics. Each would leave each other alone? Isn't that what the contract was? That's the contract in Canada. That's for sure. What happened? What happened to some country somewhere? Hey, where did it all go? Oh my gosh, I got this turned way up now. What happened there? I got so quiet. Not sure what happened. I got full. That's danger. Get your ears ready. Picking up one thing is enough, actually, for me. Interesting how it seems to be sensitive, then insensitive, and then sensitive, and now it's just going into an insensitive. It's not coming back. That's the end of the road because the pointer is bent a little bit. Let's leave it up way up high here, and we'll try to hit this with the signal generator. Oh, I left it connected. It was draining the antenna a bit. Shouldn't have had it connected, but that's okay. We heard something. That's the primary thing. So I'm up around 15.5. That's what I think that says. How about 16.5? Oh, and the pointer's way off. So I'm actually probably up around 19 meter band. Well, I guess 16 meter band. 16.5. Then I'm a little stunned there. I don't think there is such a band. 16 megahertz. It's 15,500 in that range. 15,500 is this? I don't know what's this. I've never heard of that. 16. Must be, maybe there was a different band arrangement back then. So we're going to try to put the pointer pointing into this area here. Okay, so it comes straight off. That's roughly in the area. And now we'll get the signal generator running up around 15. Numbers look funny on the video, don't they? 15. And we've got a moderate signal strength. Hello. You gotta have pretty fast ears. Anybody who listens to shortwave radio and tunes radios a lot gets to spot stuff like that. So we're at 16.8. Seems to be way off. Could be local oscillators, just not on the right frequency. We'll get to that in the alignment process. What I want to compare now is the signal strength, which is a little tricky to do over a large range. I can't be sure my signal generator will put out a consistent output over a large frequency range. But you know what? That's good enough. I think that's good enough. So what did we get out of all that? Well, yeah, see, the volume was very high, so it is really quite weak up here. But again, that could be front-end alignment issues. Or it can also be the higher frequencies are trickier to get through the circuits and the tubes. And the tubes can get older. They cannot operate at such high frequencies efficiently. So I understand. So what do we got? We got a radio here that's working pretty good now. Doesn't seem to require any other real electronic attention, even though it's got some older parts in it. I really should tend to stabilizing this. I have a plan on that. An easy way to do it. And then continue on with the alignment. So I think next step is stabilize this thing mechanically at this point, because obviously I'm going to finish this radio off. And I think that's great. I think that's really great. I think that went well. Okay, so we'll see you on the next video. Thanks a lot for watching.